Alright, next thing I'd like to talk about is using a screen blend mode. Um, I see a lot of people use screen blend mode. They use it for fog passes, for combining lighting passes, for all sorts of stuff, doing little glow effects, and that's fine. Basically, when you're compositing, if the end result looks the way you want it to look, then you've done it right. Um, but there's some things that happen when you use the screen blend mode that you should really be aware of. So let's take a look at some of those things first of all. What I did was I went back to that scene we were working with earlier, and I have rendered it again, and we've got skylight and two lights, and this is a render straight out of Max with all those turned on. And then I rendered each light separately, and I'm combining them together using additive blend mode. Turn the alpha gain down so we're additive. And if you take a look at the end result here and the end result out of Max, they're identical. If you were to screen your passes, here that's the exact same passes again, but now using a screen blend mode, you'll see it kind of gets this washed out look and does not look at all like what you would get out of Max. But like I said, it doesn't matter if your end result looks the way you want it to look. That's fine. But let's take a look at what's actually happening here, just so you understand what a screen does. First of all, I took just the ambient and key passes for now, and I'm screening them again. So it's just those two. Screen. Let me show you how a screen actually works. Here's those same passes again, and what's happening mathematically is we take each of these passes and we invert them. So what I've done is I've done a channel boolean negative, don't affect the alpha, and I did the exact same thing for the key pass. Okay, so that's the first step in creating a screen. Next thing you do is take these inverted passes and you multiply them together. Okay, so here's the result of multiplying those two passes together. And finally, you invert that again. So I did the same thing, negative channel boolean, do nothing to the alpha, and the end result is exactly the same. We've created a screen blend mode here. So now that you see what it's actually doing, and it's not at all respecting, the way light actually behaves, just be aware of that. And this sort of blend mode is great for working with if you're working in a clipped environment, 16-bit and lower, no floating point. It works fine. But the moment you start using screen and you're in a floating point environment, then you've got some serious problems. Let me go ahead and give you an example of how screening can be very destructive to your float comps. First of all, what I did was I made just a quick mock-up of an example that this happened to me on that I had to figure out on a project not too long ago. I had a blue sky, and I needed to put a sun in there, and I need to actually animate a sky like time-lapse sunset, and I needed it to at the end of the shot go to black. But if you normally turn the gain down on a shot, it just fades all your bright whites to black, and you get this ugly gray color. And so I needed to work with it in float, so that when I turned it all down, it looked good. So what I've done here is I've got my blue sky background, and I've created this little circle that's going to be my sun. And if you take a look here in this brightness contrast, I've boosted it so that it's really bright. And by the way, each of these backgrounds is in float. So both of these guys are in float. So what we get is we merge these together. I'm going to use this background node to show you what we have. If we sample this color, you can see over here everything is 1 or below. And then as soon as we get over the sun here, we jump up to 10. So our sun here is really bright. So let's say you wanted to add just a little glow kind of around here. Well, one way you might do it is to create another background, put a hotspot in there, and then we're going to, let me change this over to screen. We'll screen it on there. And now it looks fine. Everything here looks fine. You know, it's working, but what we need to notice is if we go back and we start sampling these colors, watch what happens. As they start getting over towards the sun, they're going up just like we would expect. As soon as I hit that sun, we're just barely over 1 now. We're nowhere near as bright as it should have been. It should have been 10 plus some more. So we've actually destroyed all the floating point information we had by screening this, because when you screen, it does not respect float. So the only way to get this to work correctly is to do additive. So we need to change this to an additive blend mode. Now it doesn't look all that hot, but I mean, you could adjust this and make it look the way you want it to. However, it does behave correctly. If we sample colors now, out here we're still blue sky, and watch as we go in, the numbers are going over 1, they're getting brighter and brighter and brighter and brighter, and then when we hit the sun, it's 10 plus, you know, some of the extra that was added from that hotspot. And that's exactly right. So now if we were to go in and adjust the exposure of our shot, you can see there's our sun glow going down, and it all comes back into a visible range and looks good. If this was screened and we do the same thing, look at what happens in here. We get, you know, light is being subtracted out of there because these values aren't correct. It's getting all messed up. So screening and floating point is bad. You do not want to do that. So just be aware that when you're screening, it's great, and you can do that in non-floating point comps, but as soon as you switch to float, I would try and avoid it. Alright, the next thing we're going to take a look at is performing a difference merge in Fusion. And what's cool about doing that is if you have the right combination of passes, you can isolate and create passes that you may not have any other way of creating. So what we're going to do is we're going to start with this scene here, and this is just a torus knot here and 2 lights. So what we'll do, let's render this out first. And I need to have this turned on. Okay, so here is our torus knot. And let's save that out. We'll call this difference A. Okay, and then next thing we're going to do is we're going to turn off the specular on both of these lights. And we'll render this again. Okay, we'll save this out. It's difference B. Alright, now let's jump over to Fusion. We'll load those in. Okay, so here's the one with specular, here's the one without. And now what we'll do is we'll bring a merge in, connect these together, and change this to difference. Okay, so what it's given us here is only the pixels that are different between this one and this one. And the only thing that is different between them is that we turned off specular. So here is our specular component. Now what you can do is, let's say here's your pass without. We'll connect these up, and specular should be added, so we'll change it to additive. And now we have the same result as our original pass. But what's cool is that since we were able to separate it, we now have the ability to make changes to the specular. We can make them brighter, or you can change their colors, whatever you want to do to it. You're able to isolate and get control over certain things, assuming you have the right passes to begin with. But this can get a little bit tricky, and it doesn't work in every case. It works great if you're going to be adding your passes back together, but it gets a little bit complicated and doesn't always work well if you need to put passes back together with like a multiply or other blend modes. So let's take a look at an example of another situation where it doesn't work out quite so well. Okay, so this is another torus knot here, and it's just sitting on a plane, and we have our light. So let's render this guy out. Okay, so here's that render. It's the torus knot with some shadows, and we'll call this difference Y. And what we're going to do is turn off the shadows for that light, and we'll render again. And we'll save this one out as Z. Okay, back over to Fusion, and let's take a look at what happens with these passes. Alright, so with shadows, without shadows. We'll do a difference on these. Okay, and this is correct. It's showing us just what's different. So here's what we have. Now, in order to put those back together, you actually can't use multiply, but I'll show you what happens. This isn't, this multiplying won't give you the result you want from this. So maybe if this was first inverted, let's try that. Let's say we do the negative on that, and I gotta set this to black, and just to be safe, we'll turn that off too. Okay, so yeah, as you can see, multiplying does not combine these back together, because really what's different is in here, like just the shadow portion, let's say, just right here, this is kind of a mid-gray, and here it's black. And so really, in order to get this area back to black, we don't need to combine it that way. We need to actually subtract it. So what we'll do is we'll connect these up, and we're going to change this to subtract. Okay, so now we're back to the original result, and we have the shadows sort of separated. But if we wanted to change the shadows in any way, watch what happens. Alright, see, the only thing we control is the opacity of them, which is fine, but that specular is still in there, and we can't get rid of that. It's built right into this pass, and we're stuck with it. So while you can reduce the shadow transparency, you're kind of stuck with that specular being there, like shining through the shadow. So be careful with your difference merges, or using just the difference, because you will likely run into some problems. So if you're adding, no problem. If you're not adding, you could run into some issues. So just be aware of that.